All right, so now we're going to be doing a solution walkthrough over the vectors worksheet. So in the first model, we kind of just show you a snippet of the class, the vector class. So we're giving you a class diagram, but it's only just a subset of the things that we think that you'll find the most useful for this class. You can go to the cppreference.com site to see the vector class in its entirety, but these are the subset of things that you'll want to know for CS121. So within a class diagram like this, you'll always see the two elements of a class, the member variables and the member functions. But we've kind of omitted the member variables here because we don't really need to know how the variables are stored under the hood. But what we do need to know is what member functions that we can use to perform operations on our vectors. So you can see on the right-hand side, there's a list of all the member functions of the vector class and a description of what each function does. So the first few member functions are these special member functions called constructors. They all share the same name as the name of the class, which in this case is vector. So that's how we know that these are the special functions that construct vector instances. And then the remaining member functions are, some of them we've covered in the slideshow, but they're essentially functions that we can call to perform certain operations related to our vector objects. So let's just dive into the problems. So in model number 1, the first question asks how many constructors are shown in the class diagram. So if you just go back to our class diagram, how many member functions share the same name as the class? We have 1, 2, 3, 4. So you can also check by looking at the description. So each of these member functions says that they construct a container, construct a vector object. So we know that there are 4 constructors in the class diagram here. Which member function appends values to the end of the vector container? So we just remember this from the slides as well, but if you look at the class diagram, you can just check which one of these member functions seems to add to the very end, and you can look the description for pushback. It appends the given element to the end of the container. So we know that pushback is the member function that you want to call if you want to add elements to the back of the vector. Which member function can tell us if the vector doesn't contain any values? Empty. So if you call the empty member function, you can see here it doesn't take in any parameters. If you call it this empty function, then what it will tell us is if the container has no elements within. Okay, for the next model, we just have a list of lines of code, and we're visualizing it on the right. So for every line of code here, you can kind of see on the right-hand side the effect of running that code. Okay, so let's go into the questions. So which vector constructor did we use in line number 1? So I'm just going to scroll on the side to show you. So line number 1, we're declaring a vector of double elements. So this is the data type, standard vector double, and then followed by the name of the variable that we're making. The new vector that we're creating is going to be called donations. So when we visualize that, we have a box to represent the new vector that we've made. The name of the variable is donations, and it is of type vector. So which vector constructor do we use? We know that we use the default constructor whenever we don't pass any parameters when we're constructing a vector. So in this case, because after the variable name, we don't have any parentheses, we're not passing in any parameters, it's just a semicolon. So that's how we know that we're calling the default constructor, just vector. Okay, so this table we want you to complete to indicate the number of elements in the vector container after performing code in the specified line number. So let's just walk through lines 1 through 4, and let's see if we can tell how many elements are in the vector at each step. So in the first line, we're going to be calling the pushback function. So remember, pushback adds the given element to the end of the given vector that you're calling it on. So we're adding 100.0 to the end of the donations vector. So after line number 2, we have just one element in the vector. And after, actually, sorry, the the first line, when we're constructing the vector with a default constructor, there is no element inside that vector. So we represent it like this. We don't even specify the indices because there are no elements at any index within this vector. So there are 0 elements in this vector. At line 2, after we add 100.0 to the end of the vector, we have 1 element in the vector. And then again, we're going to push back another element. So we have 2 elements by this step. At line number 4, what's happening is we're using the .@member function to do something kind of different from what you've seen in the slideshow. So you know from before that @ is a member function that allows us to access the element at the given index. But how you can also use it is to make modifications to the element at that index. So in this case, what we're doing is we're taking the element at index 0 and we're replacing it with the given value. So if you can see above, element 0 at line 3 was set to 100.0. But after running this line of code, we replaced that value with the new value 125.50. So at this point, we still only have 2 elements in the vector. All right, let's look at the next one. Where in the vector container does the pushback member function add an element? So just remember, the name pushback means we're adding to the very back of the vector. So it's C at the end of the container. Okay, line number 4 passes 0 as the argument to the @member function. So which element in the container does it change? It's going to be the very first element. So remember, with 0 indexing, the very first element is going to be at the 0th index. Okay, number 8, the @member function can access values inside a vector. So let's complete this table to specify the argument you would pass to the @member function to access the corresponding element in the vector container. So if you want to get the first element in a 0 indexed vector, then that first element will be stored at the index 0. If we want to get an element at any other index, what we generally just do is subtract 1 from the element that we want to get. So if we want to get the 30th element, we subtract 1 because we're starting at 0, essentially. And since we know that this vector has 100 elements, to get the very final element, instead of getting it from the 100th index, we get it from the 99th because the very first element is at index 0. Okay, so it's usually just whatever nth element that we want to access, it's at index n-1. Okay, number 9. What does the size member function return? So how we can answer this is just by looking at the class diagram here. So if we look at this size member function description, it says it returns the number of elements in the container. So answer here is A, the number of elements in the vector container. When using a standard vector, what values do we expect to get from the size and empty member functions after calling the clear member function? So what does the clear member function do again? Let's look at the class diagram and see. So clear erases all the elements from the container. After this call, size returns 0. So basically what's happening after we call clear is that any elements that were in the vector beforehand are now gone. They're all deleted. And the vector after is empty. So the size of an empty vector would be 0. And if we ask, is this vector empty? We would get true. And we can kind of determine these values by looking at, again, the class diagram. So for the size member function returns size type. And if you remember, size type is this special data type that kind of is just equivalent to an unsigned integer. So it's an int that can either be 0 or positive, just because C++ wants to be extra safe, and it wouldn't really make sense for us to have a size that is negative. You can't have like a vector of size -5, right? So this is going to be either 0 or positive. So in this case, an empty vector is going to be, it's going to have a size 0. And empty, it returns a bool. We can look at that return value in this function declaration here. We know that it should return a boolean, which is either true or false. And if the container has no elements, which in this case it does after calling clear, then we know that if we ask, is this donations vector empty, we get true back. All right. So for number 11, we're asking you to write some code to create a vector of customers. So let's do this line first. So if we're going to create a vector of customers, what we can do is call the default constructor using the syntax data type, which in this case is standard vector of int. We follow it by the variable name, and we do not follow it by any parentheses, because to call the default constructor, we don't pass in any arguments. Okay, so the first thing that we do is call the default constructor, and after this point, we've created the customers per hour vector that is empty. So now we want to add all of these elements in this order, 2, 4, 1, 4, 3, 2, 1, into our vector. So what we can do is use dot notation to call the pushback function, which allows us to add to the very end of the vector. So each of these lines will individually add an element to our vector. So first, in this line, we're adding 2 to the very end of the vector, and then we're going to keep on doing that with every line after. We're adding 4, we're adding 1, we're adding 4, and so on. So after these lines here that are bolded, we have our vector containing all of the elements specified in the problem in that order that we've added. So 2, 4, 1, 4, 3, 2, 1, 1. Okay, and now it asks how many times an hour was logged into the vector. And so every time that an hour is logged, we add an element to this vector, right? Because each element represents the number of visitors per hour. So every time that we have, or every element in this vector represents an hour being logged, or the number of visitors being logged for that specific hour. So if we want the number of times that an hour was logged, all we want to do is get the size of this vector. So the size of this vector, which is the number of elements within this vector, what that tells us is how many times did we log the number of customers. Okay, so what we're going to do is we call the size function using dot notation again here, and we can check the class diagram to see what size returns. So it returns size type. So when we declare a new variable called hours logged, we have to declare it with that data type. Okay. The final thing that we will do is get the number of visitors in the 4th hour and store it in a variable called midday visitors. Okay, so to get the 4th element in a 0-indexed vector, if this first element is at index 0, then the 4th element will be at index 3. So we can access the element at index 3 using the @member function, and we pass in 3. And then we can assign the return value of that to an integer called midday visitors. And then we can print out how many hours were logged here. And we can also print out the number of visitors that were at the 4th hour. All right, so that is number 11. So if we move on, I think, to the final model, we have another set of lines of code that are each being visualized on the right-hand side, just like above. So let's go down to the questions here. So we're going to match the constructor that we're using for each of the first 3 lines. So it looks like we're constructing vectors with different constructors in each of these lines, and we just want you to specify which constructor that we're using. So if we open up the class diagram, we can see the 4 different constructors here that we could potentially use. We have the default constructor that doesn't take in any parameters. we have the copy constructor that takes in a different vector and copies the contents of that vector into the new vector. We have the constructor that takes in the size that you want to specify so that you have a vector of that given size. And then the final constructor that takes in an initializer list, which will create a new vector with the given contents in the initializer list in the curly braces. So let's look at this first constructor. So we're calling the constructor that takes in some positive number. And after this constructor is called, we can visualize the vector, and it looks like that the vector is initialized with the default values. So we're making a vector of ints, and each element is initialized to the default value for int, which is 0. And we know that there are 3 of them because we're passing in the size right here. So you can tell that we're passing in, or we're calling this constructor that takes in the size. All right. In the second line, what we're doing is passing in a curly brace. Within the curly braces, we're passing in a comma-separated list of elements that we want to initialize our vector to. So this corresponds to the vector constructor that takes in an initializer list. So after this happens, we pass in 50.0 and 5.0. You now have a new vector named initial, which contains the 2 elements that you've passed in to the curly braces. And the final constructor looks like, just from the variable naming, looks like we're using the copy constructor. It's making a vector of doubles, and it's named a copy. And then within the parentheses, we're passing in a constructor that we've created already. So we already have a vector of doubles here called initial, and now we're using a constructor to copy the elements within the initial vector and put it into a copy. So now the visualization it's a little bit cut off, but we have the same elements within the initial vector here, 50.0 and 5.0, and also in the a copy vector, 50.0 and 5.0 here. So this is calling the copy constructor because it takes in as a parameter another vector, and it copies its contents into the new vector. Okay. So the lines of code that we wrote earlier in model number 2, where we push back an element individually for all of the elements that we want to add into the vector, that can be simplified using our initialization list. So we can use the constructor that takes in, within curly braces, the comma-separated list of values that we want to put in our vector. So instead of calling pushback a large number of times, we can just compress that all into a singular line. So we can define our vector of ints, we can give it a name, customers per hour, and then pass in within the curly braces all of the elements that we want to put. So all of our lines of code from the previous model is simplified into this single line of code that compactly allows us to put all of these elements within the vector immediately when constructing it. Okay, and then I think this is the last question. In the last question, what we want to do is use the copy constructor. So we have already a vector called hours placeholder. And what we want to do is take the existing hours placeholder vector and call the copy constructor. So if you remember, the copy constructor, how we use it is after the variable name, we'll follow it by a parentheses, and then within the parentheses, we pass in the other vector that we want to call. So you can look at the vector copy constructor right here. It takes in a vector as a parameter. So here, we'll define a new vector of ints called actual hours, and then we're going to pass in as a parameter the hours placeholder vector. And that way, we know that the actual hours vector is a copy of the contents of this hours placeholder vector that was already created.